different presentation from the others. It's about a tool that we did to support the work that is also already presented by our colleagues from Sixth Sense in the previous session. So just because I'm not sure how many like you or in the room at that presentation, I also have a slide or two about this. So the Copernicus, of course, you know Copernicus is not about only the data from the satellites. It's offering a number of services. It's like the marine, land, atmosphere, climate change, emergency, security. And we are producing data mainly using the satellite data that Copernicus satellites are producing, but not only that, also in situ data and another type of data, model data, and so on. So the Ground Motion Service, which is one of the newest and one of the most difficult to implement, and it's about the ground deformation caused by natural and non-natural causes. And as you can imagine, it's able to provide millimetric precision products about how the ground is moving. And yeah, it's, as I mentioned, just started. And of course, there is a lot of use for such products, but it also needs to be very carefully validated, because the stakeholders that will take decision based on that, when it comes to infrastructure or other things, they need to rely on how good the data is. And this is why we have this project, which we are running along with the European Environment Agency to create an infrastructure to validate the products. And this is what I've been talking about the component that it's about how scientists are getting the tools and facilitate the validation of the program. And it was already defined as a methodology. There are some indicators that it needs to be produced in order to assess the quality of the EGMS products. And in this activity, there are three types of actors. There is a consortium which is producing the data, and it's quite a large consortium because it's, of course, the product is at the European scale, and it's quite some amount of data, and there are many differences between countries and landscape and so on. And then we have the people involved in the validation, which is like company, like Sixth Sense or Terrasigna, but also geological institutes that have the knowledge to validate such product, and they have the tools and they have the kind of informatic programs or scripts that are good for this activity. And we'd like to work with them to create some kind of dashboard that allows scientists that he knows how to produce, let's say, scripts that are validating the data, but the aim is to do it in a homogeneous way. So as you imagine, we are all across Europe with institutions, and they need to work on the same platform to be able to have all of those the results in the same way, coherent, as I mentioned, and do this work. So, and this is a use case where we implemented such an informatic tool using technologies, only open source technologies, some from our world, like GeoPandas, Raster.io, GeoNode, GeoServer, others from other world, like Kubernetes and Terraform, Jupyter Hub, which can do a lot of things. And we set up such a platform that also has authentication and the capacity for them to work with that data, and also to have a way to display the results of the evaluation. And as I mentioned, it's a dashboard. It's a web tool, very easy to use. You don't have to be a specialist to understand it in just a few minutes, hours. And it facilitates the validation activities management. It allows the users to upload or update the data that is used for validation. And it's also, it has a Jupyter Notebook capability, and you could upload your own scripts, and the scripts will work with these vast amounts of data that are hosted in a cloud environment. So we have this kind of simple to use interface, next, upload, whatever. And of course, there is accounts, and everyone can do his work in his part of the chain and for his areas, because not everyone is doing all the Europe. We are divided in some test sites where this validation is done. And the data is stored in an object storage service that is synchronized with this Jupyter Hub functionality, allowing the scripts that they created, uploaded in this system to work on the data and also to display the results in the same interface. And then we have also a component, a catalog based on GeoNode, allowing us to have some basic metadata for all this data and to be searchable and accessible either by manually going through the web interface or using an API or a service that can automatically fetch data from here, understand what is with that data, and so on. So we have also this component, and of course in the back is also a GeoServer instance, which is the data is published in GeoServer and then consumed through classical OGC services by this tool. And here you could search it, display it on the map. If there's a temporal component, you could go in and explore it in time, having filters, be able to look at the tables of attributes and so on. Basic GIS functionalities, but done in a web environment and all integrated. So a single account for everything, and the connection with the dashboard I was mentioning. And then probably the most important task of those people involved here is to create this tests. So, and they could use Python or R. Usually in these communities, they are well used in using these languages to develop scripts that are processing data. And of course, using reference data, in situ data, you can create reports, charts, interactive maps that can be studied by anyone and make an assessment on how good, what is the quality of the ground motion, products. And this is all synchronized on a GitLab, so they actually publish this on GitLab, and from them it's fetched and get it to the platform, and then it's ready to use. So we use GitLab for that, and then once a script like this is registered there or is updated, you could run it and get results. Of course, due to the way of this activity, this is private. Most of the things are private, so they're accessible only to EA and to the partners that are in charge with that. It's not a public information, but of course the assessment in the end, it's made public for everyone to understand it. But the environment is closed and it is available only for the project team, and it's not something that the general public can go or do their own validation. It's just done by people that are experts in this field, and they know what they are doing. So, as I mentioned, you have a script. It's uploaded there. It will appear in the dashboard. You could simply see it there, and you could run it. You get all this kind of results. Like in this case, there are some charts there. I don't know exactly what they mean, but I could guess. And then you could take a look or adapt your script and see the KPIs. As I mentioned, there are KPIs and values, some thresholds, and you need to be in between those values. And this is a way to assess those KPIs, and also a nice way, it's rendered in a web page. You could get from here the content, like images or maps, and embed it in your final report and publish it as a PDF. And this is what we facilitate, and this is what this dashboard is all about. This is technical. Marianne in the back can maybe explain how is this thing on Jupyter working and doing things and reading the data and putting the data in this object storage service, and how from that it's registered through APIs automatically and ingested into the system, as I mentioned, in GeoServer and in GeoNode, in the dashboard, and so on. So all connected somehow. And we are working like this. So develop scripts on their own computers, testing to see if working on a sample data, and then upload it on the platform where you have access to a lot of data, being a cloud environment. And I think right now, so each year the EEA would like to have European-wide coverage with the ground motion product. And of course, each year must be validated. I think now is available only 2011. 2002 is, of course, in production, and I guess also the work will start soon in 2003. And the platform we developed is agnostic on the hardware infrastructure, so it could run in any cloud environment. At this moment, it's on Telesigna's infrastructure. In the future, most probably will go to Wikio, which is one of the European geoclouds, former ESA component, and will be run there. But the idea is we also produce a system that is easily reproducible and redeploy it. And it could be on a small scale infrastructure, or it could be on a very, very large one. And it can adapt and use the resources available there. I will not get into these details. This is more or less my conclusion. I think I was quite fast because maybe the subject is not that interesting, but I wanted to show how open source technologies, which are quite mature, can be used to perform a work which is important. And we are sure that in the future, the important stakeholders that are responsible in Europe for infrastructure, for instance, we will use it, and we will have they could trust it, and they knew they could rely on the data when designing infrastructure, taking measure in case of, I don't know, a landslide that's affected infrastructure, and so on, should be dealt. And it will be a completely change of paradigm at European scale. Until now, only a few countries had this kind of product, and they are not really homogenized. I mean, there are differences between countries. Now, this is looking the same in Germany, in Romania, in Czech Republic. Yeah, if there are questions, I'm ready to answer to you.
Thanks for the presentation. I just wanted to ask, what type of data can you upload that needs to be validated? Does it have to be a GNSS measurement, or I don't know, a georeference TIFF, or what type of data that you support that you can actually upload and then will be validated by the validation providers? Thank you.
So as I mentioned, we have, of course, the products of the ground motion products, and also a number of other data that you are using to validate. Yeah, it could be measurements that was done with GNSS stations or other means of measuring the displacement and so on. And it could be tabular data, it could be shapefile data. It's a range of data that, of course, it needs to be used in there. So don't know all the details because we didn't care for the dashboard. It's just be able to upload that data and just the scripts knowing how to find it and do whatever is needed with that.
The reason I'm asking is because we're actually monitoring a few areas for like 3 years, and I wanted to validate that results from 2020 up until today. I can't do that, right? Because you said it's up until 2011 at this stage?
2021.
2021, okay. So we have one. Okay, so I can actually upload my data and then it will be validated.
Yeah, if you have access to that. Yeah, so the product is based on open source, but the product itself is not open source. I see no reason not to make it open source for others to use it, but it has some specific way of working. So it's like the commission decided the workflow should go. So geologists must validate the product, and they need an environment to do it. But I think we could also make this open, and anyone could put it on his own infrastructure and running.
Thank you. I want to complete what Vasile's answer. You won't be able to upload directly the data. The data is for the experts to upload. So the final reports will be public. So basically the experts upload their own data, as Vasile said, GNSS data, whatever in situ measurements they have, and they use that to validate the EGMS data, which is public. I think it's EGMS.copernicus.eu. And this whole solution was built on top of open source software. It's used only by internal researchers, so external users cannot upload.
Thank you. Other questions?
I think you chair and present yourselves.
So thank you. Thank you very much.